Exercise 17. Examine the particle views and explain the differences between the two situations. Right? Situation 1, situation 2. Explain the differences between the two situations pictured below with regard to what is or is not reacting and the total yield of ammonia. And so we have a balanced equation. Here's the ammonia. You need to know that it's ammonia. And we have nitrogen reacting with hydrogen gas. Okay, and I need one of those for every 3 of those to make 2 of those. And so down here in the little key, we see that the small diatomic is hydrogen, the larger diatomic is nitrogen, and the larger compound is the ammonia that we're trying to make. And the nice thing that they've done here is they've actually packaged everything together with little dotted lines, so we can see that we have one of those for every 3 of those, one of those for every 3 of those, one of those for every 3 of those, and on and on. And because when we have one of those for every 3 of those, we get 2 of those. When we see the reaction happen, look, in each one of these little packets, we got 2 of them, right? We got 2 ammonias. And so we have, 1, 2, 3, 4, 5 little pockets. So 5 little pockets, each making 2. We should have 10 ammonias. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 NH3s as our yield, right? We got 10 of those. Now, how is that different from situation 2? Okay, so we have encapsulated, our packets with our dotted line here. 3 of those for every one of those. 3 of those for every one of those. 3 of those for every one of those. But notice that we have these extra nitrogens floating around here. We have 2 extra nitrogens and no hydrogens to react with them. Because in order for this reaction to progress, we have to have 1 nitrogen for every 3 hydrogens. Inside the dotted lines, we get the stuff to react like it's supposed to. So we get 3 of these actions to happen, right? And remember, each little packet makes 2, so I'll have 1, 2, 3, 4, 5, 6 ammonias. I'll have 6 ammonias. But because I didn't have enough hydrogen to react with these nitrogens, they stay there. They do nothing. And so left over, I have 2 nitrogens. And so what's happened here, in terms of explaining the differences between the two situations, in situation 1, there was exactly the appropriate amount of hydrogen and nitrogen to react to make ammonia in such a way that there were no limiting reactants. There's no limiting reactant because nothing's left over. In order to have something limit something else, the other thing must have something left over. There's nothing left over here, so there's nothing limiting. But over here, notice that we have 2 nitrogens left over. 2 nitrogens left over. So this means that the nitrogen is in excess. So if the nitrogen was in excess, which species was limiting? The H2 is limiting. Now, the reason that this exercise is here is not because this is difficult. I'm not even going to take the time to write out this response. The reason that this exercise is here is because the AP exam has been redesigned. It's been several years now, but these types of questions appear on the multiple choice portion of the exam quite a bit because it's important for you to know the conceptual backing behind math. The AP exam, at least for chemistry, has moved away from having you do math just for math's sake. They're really trying to make it so that you do math to show your understanding of what reality is doing. And this is what reality is doing. Anytime we focus on a particle view, it's conceptual, right? We're trying to understand what is happening on this micro stage so that when we do math using this information, right, we can conceptualize what's happening at this particle view and then give a really nice long free response on the FRQs.